This project is about comparative study of recycled aggregate by Ashok Manigandan. The aim of the project is to compare the recycled aggregate concrete with conventional concrete by partial replacement of aggregate. The scope of the project is to recycle stone and aggregate, which will reduce the quarrying and mining for stones. The earth surface can be saved and ecological disturbance will be reduced. Availability of land for waste disposal will be increased, and to conserve the conventional natural aggregate for other important works. Our objective is to investigate the behavior of concrete while replacing used foundry sand and construction debris in different proportion in concrete, and to reduce the demand of natural aggregate. To emphasize reduce, recycle and reuse concept in current construction field, and this one is the best tool adapted for effective solid waste management. This is the methodology in which we did our project. Literature survey. These were the various journals and papers which we referred for our project. Introduction. Construction and demolition waste constitutes a major portion of total solid waste production in the world. Construction and demolition waste is generated whenever any construction and demolition activity takes place, such as building roads, bridges, flyovers, subway, remodeling, etc. These wastes are heavy, having high density, often bulky, and occupy considerable storage space, either on the road or communal waste. Concrete waste can be recycled by sorting, crushing, and sieving into recycled aggregate. This recycled aggregate can be used to make concrete for road construction and building material. Foundry sand is high quality silica sand with uniform physical characteristics. It is a byproduct of ferrous and non-ferrous metal casting industry, where sand has been used for centuries as a molding material because of its thermal conductivity. It is a byproduct from the production of both ferrous and non-ferrous metal castings. Generation of waste foundry sand as byproduct of metal casting industry causes environmental problems because of its improper disposal. Thus, its usage in building material construction and in other fields is essential for reduction of environmental problems, and thus we have used foundry sand as our fine aggregate. We have collected samples from Kuthambakkam village, Poondamalli, and we collected from coarse aggregate from Kuthambakkam village, Poondamalli from Advanced Construction Technologies Private Limited, Chennai, and we have collected foundry sand from Lakshmi Works, Gindi Industrial Estate. This way we processed our samples by heating and rubbing so that it is fit for using further. These were the various tests which we did on coarse and fine aggregate. The first and foremost is impact value, specific gravity, water absorption, and for fine aggregate we did fineness modulus test. And these are the various data which we gathered. And these test results is for both natural aggregate and as well recycled aggregate. This is the mixed design which we have adapted, and we have followed M25 grade concrete. The water cement ratio for our mixed design is 0.4%. 0.4. We have followed 20%, 40%, 60% replacement of both coarse and fine aggregate, and the detailed specification has been given in this tabular column. The various material which we have used are foundry sand, recycled coarse aggregate, natural coarse aggregate, sand, and cement. Mold dimensions: cube 150 by 150 by 150 mm, cylinder 100 by 200 mm. Concrete casting. This way we casted concrete in a cast iron mold. We damped it. We left it to set for some time, for a day, and then we threw it into the concrete curing tank. These were the hardened concrete test which we did in our samples. The first and foremost is compression strength test, which we did using our cube of dimension 150 by 150 by 150 mm using CTM compression testing machine. These were the various test results which we obtained. For the conventional concrete, 20% replacement, 40% replacement, 60% replacement, respectively for 7 days, 14 days, and 28 days. And as we can see, 40% replacement has got maximum expected result, optimum value. This is the graphical representation of a compressive strength compression test results. The x-axis consists of percentage of recycled aggregate and y-axis consists of compressive strength in Newton per mm square. The second hardened concrete test, split tensile strength test, which we did with our cylinder of dimension 100 by 200 mm using the same CTM machine, that is a compression testing machine. These were the various results which we got split tension test for 0% replacement, 20%, 40% and 60% replacement for 7 days, 14 days and 28 days respectively. As we can see in this also, 40% replacement has got maximum optimum value. Split tension test graphical representation. The x-axis constitutes of percentage split tensile strength in Newton per mm square, and the 40% replacement has got maximum peak that we can easily infer from the graph. Comparative study. First and foremost is a compressive strength, in which we have compared both the recycled aggregate concrete value and natural aggregate concrete value. And as we can see, the 40% replacement has got the maximum expected value, optimum value in recycled aggregate. The second one is split tensile strength. In this also we have compared recycled aggregate concrete with natural aggregate concrete for 28 days. Here also 40% replacement has got the maximum optimum value compared to 20 and 60% replacement. Conclusion. Based on above study, the following observations are made regarding the properties and behavior of concrete and partial replacement of aggregate by construction debris and waste from recent. In this study, maximum compressive strength is obtained in 40% replacement. Strength decreases on increase in replacement of aggregate. The second is split tensile strength decreases the increase in percentage of replacement. The workability of recycled aggregate concrete is lower than natural aggregate concrete because the absorption rate of recycled aggregate is higher than natural aggregate. Use of waste foundry sand in concrete reduces the production of waste through metal industries. It is an eco-friendly building material. Due to use of recycled aggregate in construction, use of waste foundry sand in concrete reduces the production of waste through metal industry. That is, it is an eco-friendly building material. Due to use of recycled aggregate in construction, energy and cost of transportation of natural resources and excavation is significantly saved. This in turn directly reduces the impact of waste material on environment. The problems of disposal and maintenance cost of landfilling is reduced. Thank you.